Okay, let's dive right into this. Welcome to this explainer on the realities of modern stealth technology. Today, we are unpacking the absolute incredible engineering behind machines that can literally fly undetected to the most heavily defended airspace on Earth. We're talking about altering the entire balance of global power without making a single sound. So, we're going to break down exactly how these billion-dollar systems completely rewrite the rules of aerial warfare.
Now, right off the bat, we need to totally shatter a really popular sci-fi myth. You know the whole invisibility cloak idea? Yeah, forget it. When we talk about stealth technology, which, by the way, the industry calls low observable technology, we are not talking about some magical vanishing act. The real goal of stealth is never complete invisibility. It's actually just about delaying detection. That's it. It's this highly calculated, high-stakes game of time and distance. The tech just buys the platform enough time to slip into enemy territory, strike its target, and get out safely before the defense systems can even figure out what's happening.
To really visualize how this works, imagine you're holding a flashlight in a totally pitch-black room. That flashlight, that's the enemy radar. A normal aircraft is essentially a giant mirror flying through the sky. If you shine your light anywhere near it, boom, a huge bright reflection bounces straight back into your eyes, and you instantly know exactly where it is. But a stealth aircraft? It's more like a black velvet ball covered in tiny little pyramids. When your flashlight beam hits it, the velvet actually absorbs the light, and those little pyramids scatter whatever's left in completely different directions. So you might eventually see a tiny faint glow, but by the time you actually pinpoint it, game over. It's way too late. So, now that we know stealth is basically a black velvet ball, here is our roadmap for today. We're going to cover 1, the myth of invisibility, 2, how stealth defeats radar, 3, masking heat, sight, and sound, 4, the strategic edge, and finally, 5, the high cost of stealth. Section 1, the myth of invisibility. Like we just talked about, it's all about getting in, striking, and leaving before the enemy even blinks. Moving to Section 2, how stealth defeats radar. This brings us to the absolute most critical sense an enemy has, and how engineers physically manage to blind it. So to defeat radar, you basically have to break the echo. Just as a super quick refresher, standard radar systems work by sending out radio waves that bounce off an object and return to the receiver. It's like shouting into a canyon and listening for the echo. Stealth engineering is completely 100% focused on stopping that return trip. If you kill the echo, you render the enemy's most important sensory network completely useless. And this brilliantly illustrates how engineers actually pull off this physical evasion. They use 4 main pillars. First up, shapes and angles. Stealth platforms use mathematically calculated flat, angled surfaces to just bounce radio waves harmlessly away into the atmosphere. Second is RAM, or radar-absorbent material. These are highly classified, specialized coatings that literally absorb radar waves and convert them into heat. Third, internal weapons base. Think about it. Missiles hanging off the wings would create massive radar reflections, so the payloads are tucked safely deep inside the belly of the plane. And finally, smooth, seamless surfaces. Even a tiny, microscopic gap or a single protruding rivet can scatter a radar wave. Because of that, these jets are built to just unprecedented, razor-thin tolerances. All right, Section 3, masking heat, sight, and sound. Because defeating radar, that's just the start. A ghost also has to hide from infrared sensors, eyes, and ears. Here's the thing. Jet engines produce an insane amount of heat, sometimes well over 3,000 degrees Fahrenheit. That makes thermal masking a phenomenal challenge. I mean, if you're invisible to radar but you're glowing like the literal sun on a thermal camera, you're still going to get shot down. So engineers tackle this in 3 rigorous steps. Step 1, physically shield the exhaust nozzles from below so ground sensors can't see the hottest core. Step 2, actively mix that scorching hot exhaust with freezing cold outside air right before it leaves the jet. This drastically drops the temperature. And step 3, they use these really unique, non-circular, kind of flattened nozzles. That spreads out whatever heat is left as fast as possible so you don't leave a concentrated thermal target in the sky. Now, visual masking is pretty straightforward. It relies on dark radar-absorbent paint for night missions, unique silhouettes that sort of blend into the sky, and flying completely lights out. But the real operational discipline, that comes with acoustic and electronic masking. A stealth pilot can't just casually chat on an open radio frequency or blast their own active radar. That kind of electronic noise is basically shining a beacon to listening enemy antennas. Remaining a true ghost requires incredibly strict radio silence, relying only on passive sensors and running advanced electronic jamming. Section 4, the strategic edge. Let's talk about the massive tactical payoff here. So why does all of this matter to modern geopolitics? Well, because stealth completely flips the math of a military campaign. It allows aircraft to survive high-threat areas, literally flying right through dense modern air defenses that would instantly shred standard planes, and that grants a crucial first-strike capability. It's the power to decapitate enemy command centers or completely blind their defenses before they even realize a war has started. It is the ultimate force multiplier. Because a stealth plane is so elusive, it doesn't need a huge, sprawling escort of fighter jets or a dedicated jamming aircraft. One single jet can do the job of a dozen, which drastically lowers the overall risk to pilots and equipment.
Section 5, the high cost of stealth. Time to look at the harsh operational realities.
So, the crucial point is this: $2 billion. That is the staggering cost of just one single B-2 Spirit bomber. It's an astronomical number, but it impartially highlights the absolute extreme financial burden that comes with developing, building, and operating these low observable platforms. And you know, the profound irony of a $2 billion ghost is that it's actually remarkably fragile. Those highly classified, super expensive radar-absorbent coatings, they degrade from friction, high heat, and literally just flying through the rain. It requires constant, painstakingly expensive maintenance. Operationally, their weapon payloads are heavily restricted because, remember, everything has to fit inside those internal bays. Furthermore, the entire stealth illusion completely shatters the very second a pilot opens those bomb bay doors to drop a weapon. And here's an interesting quirk. While they easily evade high-frequency targeting radars, modern low-frequency radars can actually detect them. Now, thankfully for the pilots, those massive, clunky radar waves aren't precise enough to actually guide a missile to the target, but the enemy still knows something is out there. Let's move to and see how this builds across actual military history. Looking at real-world evolution, we see the 1980s F-117 Nighthawk. It relied on a highly faceted, kind of diamond-like shape because, well, early computers couldn't accurately calculate radar cross-sections for smooth, curved surfaces. After that came the B-2 Spirit, which utilized this sleek flying wing design with literally no vertical tail to catch radar waves. Then the F-22 Raptor and the F-35 Lightning I successfully combined that curved stealth shaping with supersonic speeds and insane sensor fusion. And hey, this tech isn't just for the sky. The Zumwalt-class destroyer uses a unique tumble-home hull design and sharply angled surfaces to drastically shrink its radar signature out on the open ocean. As we wrap up this explainer, I want you to consider this. Beyond the incredible engineering, the ultimate weapon of stealth might actually be psychological. Think about it. If an adversary never knows when, where, or even if a stealth platform is going to strike, how much time, energy, and national treasure must they spend living in constant paranoia, trying to build countermeasures against literal shadows? It entirely shifts the balance in modern warfare. Thanks so much for joining me on this deep dive into stealth technology. Keep learning, keep questioning, and I'll catch you on the next explainer.